Okay, welcome back. I hope you had a very happy hour developing our midterm project, is it? Okay. Maybe if you feel overloaded, you are welcome to discuss with me, okay, if you need any help. For me, the best thing is the best result is that you finish the project. Not, uh, not, I'm not mentioned to put a huge block on your learning process. No, that's not my goal. My goal is to smash the rock with you, okay? To overcome the difficulty with everybody. That's my goal, okay? So if you need any help, you're always welcome to contact with me, and I will gradually help you to finish the project. All right. If you finish the midterm project, congratulations, and let's move on to a very interesting topic that is about to make a first person or a third person control in the game. If you are interested in making a third person game or playing a third person game like this, and this one is Black Myth. It's a trending game recently released by Tencent. Yeah, Tencent. The game manufacturer from mainland China. So we can play the game at the same time while I need your help to look at the character, the player over here, and to observe how many action this player can do throughout the game. And understand? I need your help to analyze how many actions the character can do in this game. For example, he can walk, he can pick something, pick some item, he can move towards front, backwards, left and right, even in a slanted angle. Oh, now he's attacking. He can do some attacking animations. He's rolling, and this is a special skill of this monkey king. Yeah, he's a monkey king. So if you never let me pause it here. Let me pause it here. If you never play any third person game before, I think it will be a little bit dizzy for you to look at the screen over here. That is because actually you have two controllers. Let me show you the controller. PS3 controller. This is a traditional one. Typically, you are going to use your thumbs. We have two thumbs, the left thumb and your right thumb. So you are using your thumb to control the joysticks over here. You have two joysticks over here. For the left joystick, you can move your character. For the right joystick, you are allowed to move your camera angle. So the reason why you are feeling a little bit dizzy is because this player he is controlling the camera with the player at the same time. So sometimes he's rolling the camera, and whenever he rolls the camera, you'll feel some dizzy feelings. So that's why whenever you are going to rotate to another camera angle, the screen just suddenly scroll the angle. So you can control the camera and the character movement at the same time. All right, so let's go to another traditional, very classic game, and it's Dark Souls. Where's Dark Souls? Wait a minute. Dark Souls. Oops, that's too bloody. Uh, and this is the protagonist, and this is also the player. Oops, too many effects. Uh, well, actually, this is a little bit bloody for me. And okay, let's pause that here. Actually, you can do the same thing comparing to the last example. You can rotate your camera, and at the same time, you can move your character in different direction. You can move your camera to leftward, but moving your character to the rightward. So you have two joysticks. We see the function again. Alright, so the same logic will be applied to Super Mario 3D, or you can even find the same moving logic in Zelda or some similar game which is made of a third-person camera mechanism. Right, so I think you fully understand the idea about the controller. Alright, so let's go back to the lessons. So today we're going to make our player controller from zero, from ground zero. We'll write all the code from zero, and you'll learn how to develop the structure of a player controller, and the controller will for the top-down view gameplay, top-down view. So at the same time, we're going to apply design patterns. So we know that the software design pattern, we are going to implement the template method and the observer patterns in our controller. So it's very cool. I thought that some of the students have learned something from the from the YouTube channel, right? So probably you learn how to make a player controller from YouTube channel. That is very good, very good. But there aren't so many YouTubers make their games using design pattern. So that is a problem. If you apply for a job that is a professional software engineer in game industry, you have to know design pattern because your uh, senior classmate or your senior collaborators, your senior colleagues, they write their code with some patterns and they deliver the code to you. You have to read all the codes in the shortest time. So without a clear structure, you are not able to read the code in a very short time. On the other hand, without the help of patterns, you will never understand the code released from your colleagues. So pattern is sometimes like a secret keys, a secret language, which is used by so many software engineers. So we have to learn it. So the objective of this lesson is to understand the fundamental principles of object translation and object rotation in game development. And we are going to use rigid body also. Rigid body is the function provided by physics engine. The physics engine used by Unity 3D is called the physics. Actually, physics is provided by NVIDIA. It's bought by the NVIDIA company and released to everybody. So you can use, I can use, everybody can use. So Unity utilizes physics as its physics engine, and Unity just packed everything into rigid body component. We're going to use it today. And we're going to review the process of creating and managing an animator for character animation. We should have introduced animator in Unity before in second year lessons. And if this is the first time you encounter animator, it's okay because we are not going to make any complex animator. Okay, so yeah, we're going to gain proficiency in coding, gain object movement. Yeah, right. Mm, okay, so let's move on to the next slide. Before we write any code, I would like to introduce the structure of our player. So this is our player. Ta-da! So we see CE again. For game prototyping, we always use capsule. So this is the same. We are using the white capsule over here. So I'm going to call this white capsule a player handle from now on. The player handle. Let's see the components. The player handle serves serve as the primary container and the collider. So do you remember I was talking that we are going to use physics, the physics engine provided by Unity 3D, right? So we have to we have to describe the volume of the object to physics. So this is a capsule, and the position of the capsule is 0, 0, and 0, and the volume is like this. The radius of the area will be blah 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 blah, and the height of this capsule is blah 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 blah. So after we describe every feature of the capsule to the engine, it can calculate the Newton's law, the gravity, and the acceleration for us. So it's the duty of the handle to save all the information of the physics features. So that is the handle. And then we see there are two little guys over here. The first the little guy is the model. So what is a model? A model is the real mesh provided by your artist to serve as a visual representation of this character. So again, we see the word visual representation again. So in our lessons, we always separate our logic design and our visual representation into two parts. That is because these two parts always owned by two different artists and engineers. If you are a software engineer, you're going to take over the logic design. And if you are an artist, you're going to take over the visual representation design. So we always separate these two tasks into two different working progresses. All right, so the model is provided by your artist. Today we are going to download some already made asset from the asset store to serve as our models. And just like this, this is the visual mesh of the character, which can be a static mesh or a skinned mesh. So does everyone knows what is the difference between static and skinned mesh? Uh, so for the students who learn in the second year, we introduce. Do you remember the rock? We make a gate from a rock, right? At that time, the rock will be duplicated several times to serve as a brick, to serve as the element for the gate, right? The rock doesn't contain any skeleton, so that is a static mesh. On the other hand, later you are going to see a cute girl like this. The cute girl can serve as a player to make all the animation you want. That is because the girl owns a skeleton. So for these kinds of skeletal mesh, we call it a skinned mesh, aka a skeletal mesh. So both these two terms are valid to call this kind of mesh. So a rock is obviously different to a girl. So one is called a static mesh, the other is called a skinned mesh. The model could be either a rock or a girl. So the model, of course, can either be a static mesh or a skinned mesh. So sometimes we are going to make a space shooter game. So do you know space shooter game? Like the invaders, the classic one. So if your player is the player for the invader for the shooting game, of course it is a spaceship. I never see any spaceship have a skeleton. Do you? That is no need unless you are making a Gundam. Do you know Gundam? Of course, but if you are going to make your player a spaceship, then the spaceship typically will be a static mesh. On the other hand, if you are going to make a game like Dark Souls or Zelda or Super Mario, then your player should be a skin mesh, right? Mhm. And the second little guy is a sensor. What is the need for a sensor? Sometimes the player need to sense the environment which surrounding him, like whether the character has a ground beneath the player, or if the player can see a range in front of him, For example, he can see a corn shape uh, viewing angle just in front of him. Then you can put it as sensor in a cone shape and just tie to the player. So the sensor can sense the area and provide some information to the player. So that is sensor. All right. So let's make the character structure. So let's skip several slides and jump into the example over here. This is page 14. Page 14. So let's go to page 14. And we are going to download the asset today. It's Casual One. So let's search Casual One on Unity Asset Store. Asset Store, unity.com. Oops, Casual One. Maybe set the price to free. Okay, it's a free asset. Of course, you can choose your own character. I just need a Unity humanoid character. What's Unity humanoid? If you don't know what is Unity humanoid, you just download this one. Okay, you just download the casual one. I'm sure this one can be converted to humanoid model. All right. So if you have problem, download the asset. Probably you need to connect to your private Wi-Fi network because I'm not sure whether NTUT block the asset store or not. All right. If the school network block the asset store, then I'm going to upload the asset by myself. Please wait me for a moment. Uh-huh. It looks like it's blocked. Wait a moment, please. Okay, I'm going to upload the asset folder to our iStudy. Please wait for a moment. Okay, I just upload a zipped file, which having an image girl. This one, I think, uh, you can directly extract the content and pull it into your project as a folder. Okay. All right. So, there are several folders and files. I need your help to put everything into your project as a folder. Okay, in the subfolder of Kjo1, you'll be able to find a prefab, and the name of the prefab is also Kjo1. So later we are going to drag the prefab into the scene, but not now. So before everything, the first thing we are going to do is to add a capsule. So let's open Unity, create a new project, and adding a capsule to the scene. So we know that the capsule is a 3D object, and we can find a capsule over here, and we are going to reset the transform. So here comes some problem. So if we see the capsule from a side view, we see that the capsule is sinking to the ground. So if we put a ground in the scene, let's put a plane and reset the plane to 0, 0, 0. It's too bright for me. I'm going to add a gray colored material, gray, and this is for my eyes. It's too bright for me. Okay, now I feel better. The position of the plane is 0, 0, and 0. So the plane can be taken as a ground. Wow, so now the capsule is sinking to the ground. So what should I do? Problem number one, what should I do? So you may say that, hey, Mr. Fu, I'm going to leverage to make it higher like this. I'm going to make the y position of the capsule to be 0, 1, and 0. No, never do that. We should put the capsule to be exactly at the position of 0, 0, and 0. But we are going to uh, make the capsule higher. The capsule is over here. Do you see a capsule collider which is attached to a capsule? Yeah, this one is the collider. So let's make the center of the collider to be 1. And we don't need the mesh filter and renderer, so we are going to remove the capsule, remove the rendering white capsule. So this is the one we want. And I'm going to make it a player handle. Just change the name, player handle. So you may ask that, Mr. Wu, why I just can't make the Y position of the handle higher? That is because the position just represents where your player is. If you move the handle to a higher position like Y equals to 1, that means your player is flying in the air, right? Because the Y position of the player is always flying in the air, that's not reasonable for me. So for me, the player should be always on ground. So the Y position should be 0. So if this is what I want, the capsule collider should be pulled higher into the air. So let's see the configuration over here. Since now the capsule collider having a height of 2, that means the center of the collider is 1 because 2 divided half of 2 is 1. On the other hand, the radius is 0.5. This is acceptable. So this is the capsule handle over here. So once we have a player handle, the second thing is to put the model into it. So did you remember the casual one, the prefab? So we are going to drag the casual one into the player handle. So if we didn't see any green wire, that is because we have to select player handle. Oh, we see that the model is a little bit smaller to the capsule, right? So we are going to tweak the setting of the capsule. Maybe the growth is 1.7 in this in her height. So I'm going to change the height to 1 point, maybe 1.6. Okay, so if the height is 1.6, then the center would be put to 0.8. Okay, now it seems like the girl is encapsulated into the capsule. Great. So this is the final configuration of the capsule collider. All right. And we need a sensor, but right now we have nothing to sense. But we're going to put a sensor in the middle of the character. So let's add a sphere, and we just put the sphere higher, and we just remove the mesh filter. We don't need to render the sphere. We don't need to render the sphere, and we're going to make the radius smaller. Just make it 0.3. The position is not so important. You can put any position you want, but be sure to put the sensor inside the capsule. Next lesson, we are going to use the sensor to sense ground, but right now we have nothing to sense. So just put it inside the capsule, that is okay. Alright, that is the player structure we made. Okay, so we are going to take about 5 minutes to assemble the player structure. Okay, the detail will be no. The detail will be listed on page number 14. Okay, if you need a model, it should be put on our iStudy. The zip file is anime girl, this one. 那是 RPG battle，那只是 background 吧？这么有爱，太好了，太感动了。哦，谢谢。啊，就是午餐放在这里。哦，那边好，谢谢大家下课了。Okay, if you are still busy, if you are still busy making the structure, is okay. You can listen to me at the same time when you're working with the structure, and I'm going to explain a little bit about the theory behind, including some 3D math and the way how Unity process with the position and the rotation. So let me go back to page number 7. Okay, in the beginning, I'm going to explain the axis, the coordinates of the world in Unity 3D. So probably let's look at the image over here. Probably you learned this gesture in your physics class in your senior high school lessons, right? It's about some electricity or magnetic theories, and this gesture we call left hand gesture. We use three fingers in perpendicular angles to indicate an order of 3D axes. So the thumb is pointing to x direction, to positive x direction, and uh, your index finger is pointing to the positive y direction, and your middle finger is pointing to the positive or z direction. So x and y and the z, and you are using your left hand. So we call this left hand system. Okay, the unity axis is in coincidence with the left hand system, but Blender is not this situation. Blender is right hand, X, Y, and Z. Think about Blender, right? That's why it's why maybe I don't remember. I have about 6 years never opened my Blender. Last time I modeling was about 5 to 6 years ago. And later I met Professor Zhuang. So Professor Zhuang teach modeling. Now I don't need to teach modeling. Okay, just kidding. Okay. All right. So the second thing I'm going to mention about is the global axis and the local axis. So let me go back to Unity Editor, and we see a little gizmos over here. This is the world gizmo, the global gizmo. It shows the three axes of your global axis, including the x and the y and the z. And if we look at the player handle, whenever we select the player handle, you can find another gizmo which will be on the origin of this scan object. So right now I'm in local mode, right? So if I rotate my model, I'm going to see that my local axis will rotate too. And at this moment, the local gizmos shows different axes to the global gizmos. That is because I have some rotation angle for my selected gain object. So if I make her rotate again, so this is totally different gizmos. But if I switch the mode to global, then these two gizmos always pointing to the same direction. No matter which direction you rotate the character, its gizmos is always showing the global direction. So this is global mode. I personally always use local mode whenever I developing a level. So this is for your reference. I'm going to rotate the character back again. So this is global and local axis. And the last thing is about the pivot mode. So the pivot mode has center mode and the pivot mode. And if I'm going to select the pivot mode, the axis, the gizmos will be put at the origin of the selected object. But if I switch to center mode, it will take consideration to all of its children to calculate the average position of each of the of whole of the objects, and only shows the gizmos on the average position. So right now the average position is over here. So this is center mode. If I put the model to another position, you can see that the center position just moving to the right hand side. If I drag further the model, and this center position changes again. You see that? Yeah. So let me go back, put the model back to here. I personally suggest that you always choose pivot mode. So the local and pivot is 99% when I'm working editing the level. Right. So now, if you understand the global and local axis, I have a little question for everyone. What if I have a parent-children relationship like this? Let's look at the image over here. In this image, the grandparent is cross. The cross. This is the cross. He is the grandfather. And the grandfather, father, and child. The grandfather is a cross, the father is an arrow, and the child is a sphere. So this is the relationship from parent to the last children. So considering the global position, the grandfather has a position of 0, 0, and 0. The father has a position of 2, 0, and 1. Now we are looking at the x and z axis. So y for the y position, all the y position are 0. So this 2, 0, and 1. This is the global position of this arrow. And the position of this sphere should be 3 and 2. 3, 0, 2. So this is how the global position are calculated. But what is the local position of each of the gain objects? The local position is derived from subtracting by subtract your position from the parent position. So for the position of the arrow, we are going to subtract 2, 0, 1 by 0, 0, 0. So the result is 2, 0, and 1. This is the local position of this arrow. He is the father. And the local position of the sphere is derived from 3, 0, 2, and subtract 2, 0, 1. And this will derive the result of 1, 0, and 1. This is the local position. Simple math, right? All right, so this is the equation. The global position could be calculated by parents' global position plus the children's local position, or we can move the term to the other side of the equal sign. Okay. Okay. Now here comes the important things. In Unity, if you want to read the local position, you're going to read the field over here. The local position is transform that local position. But in the editor, the local position is marked as position. See, the position here actually is local position. So this is the ambiguous thing. Whenever you found some material on internet, okay, let me put it again. The position listed over here is actually the local position. If you want to read the number of this field by C sharp, you have to read it like transform that local position. On the other hand, in C sharp code, when you are reading transform that position, actually this is the global position, not the position in editor. All right. Mhm. Be careful, because for beginners, when a beginner is trying to use C sharp to read the position, sometimes I see that students have some errors made from this. Okay. All right. Next, so after we know what is local position and the global position, we want to move our gain object freely. So we have several different ways to move a game object in Unity. They can separate it into two categories. The first category is moving without a rigid body component. This is the case like this right now. If we want to move a game object which doesn't carry any rigid body component, you can just move it by assign the position of it. So we know that the position could be set and get from transform that position, right? This is the manual, but we are not going to check the manual right now. So we can assign the position directly uh, like this. We can assign the position to some vectors, and the vector have three dimension, right? So the value of the three dimension will be right into the position. This will override the s and the y and the z of the position. So by directly override the position value, we can move the transform. We can move the gain object to some other position. Great, and sorry. The second way to move sorry, not this one. The second way to move a gain object is to use the transform dot translate. Actually, this is doing the same thing as you move the position directly. So you can choose either one from them. It only depends on your habits. Okay. But translate, you can translate anything in local access. This is much more benefit for me. Sometimes I don't need to recalculate everything and transform every vector back to the global and back to the local again. This is tedious for me. So sometimes translate offers a convenient way when we are trying to move something in local access. Later you will see that. Okay, this is the first category. The second category is moving some object with rigid body. Before that, I would like to introduce what is rigid body, but probably in your sophomore year, I already introduced for once. All right, before that, let me introduce the physics engine, which is used by Unity, the physics. Physics is bought by the NVIDIA. In the beginning, physics is owned by another company, and now the company is acquired by NVIDIA. Physics is open to anybody. That means me, you, and anybody who would like to implement a physics game can use physics freely. And once you use your engine or your game with the help of physics, your game could be accelerated. Your game can be accelerated when it runs on some NVIDIA cards. Good news, right? So if you incorporate the physics engine into your game, and then you sell your game on Steam or some other platform, and your customer buy your game and back to his PC and run again, wow, then the physics is accelerated by his NVIDIA cards. Sounds great, right? But unfortunately, it doesn't happen on Unity game. It seems that Unity doesn't turn on the physics on NVIDIA cards, so the game made by Unity will not get accelerated on NVIDIA cards. This is uh, this is the situation 3 years ago. Uh, I don't know what is the current status right now. Maybe the Unity engineer fixed the problem, but originally, this is the physics engine. So how do everything negotiate with the physics engine since they are run in different threads? Do you know threads? We should introduce the idea of computer thread, operation thread before. Um, the code we write will be executed on game thread, which we will consider as a main thread. But the physics engine is running on another thread, which is called the physics thread. So the two threads runs in different interval. They have to be synchronized. The answer is rigid body. Whenever you add a rigid body component to a game object, the rigid body will take the responsibility to synchronize the position, rotation, and scale with physics engine. Get it? So let me put it again. All the game object we are running and we are making some scripting for the object. All this information is running in main thread, which is having an interval of 20 milliseconds, namely the 60 frames per second. This is main thread. But your physics is running in another thread, which is typically 50 hertz, 50 times per second. So they are running in two threads. So it's the duty of rigid body. It's a，你帮我跟敏捷联系一下。你有敏捷的联系电话吗？没有。Okay, it's the duty of rigid body to synchronize the position, rotation, and scale between these two threads. Okay. All right. I think we can take a 10 minutes coffee break, and after that, we're going to introduce the idea of how to move a GAN object by rigid body. Okay. Okay. Let's take a break.
他之前他的专辑是直接给我一个高机器，他就写，这样多我持续来才是因为没有进步，是我觉得是然后这个就是最好的，真的。你想说为什么？就是你们还喜欢要求我想要写这个专，
我觉得很开心啊，就是来，
我愿意画心，
应该是要跟互动系，因为我们互动系也是有走知的，但是
没有很
但是他们过往几届都，我觉得毕业之前有些课都没有去修到，所以我也希望他们去这东西，不然的话，如果硕士班要再接回来，就会有很多科目会来不及。就像这一次大家互相交换一下。
木头没见过，没关系，我把电话给老师一下。好，这个讲了。好，是并进。谢谢，喂，雨杰，
哦，
好，是你。
那我想想看，你现在是在哪边啊？台北地下街。那你是大概看了几间都没有，对不对？那就，可是他如果是亚克力的话，可以去北调嘛。
没事。
还是楼？
亚克力到处都。
塑胶，我知道现在如果是塑胶的话，它能北调吗？嗯，应该。那轮你有雷雕过塑胶的吗？亚克力听说可以没错。嗯，可是亚克力它是黑色的吗？白色的，白色雷上去，那个多少钱？ 呃，我觉得今天至少跑一趟不要空手而归，能不能先利用500块以内的经费先挑一个回来，然后经验了这几天赛，赶快先试试看。如果一试就成功，那也是好。因为我们都没做过嘛，你先看看，今天先拨500的资金出来，今天找一个东西买回来，然后试试看。然后如果你觉得需要再提高这个资金，你要再跟我说。好不好？好，挑一个，谢谢，谢谢，谢谢。好，好，拜拜。
机器，没关系，我们所以没关系，我们公司有，反正做的东西，那如果交如果要里面基本上可以放照方面会比较有效，那你就是一定会有退步的，因为你们不行，一定会有退步，那是点。不过这些都是我没关系，因为所有每一天的状况，然后到时候我会看上，因为通常老板因为现在都会打上下都会。今天上完场地，如果你球可以过掉，对，啊，变成我那扣分呢
Okay, so sorry for keep you waiting. Okay, welcome back. Okay, just like we talked before, there are two categories of moving a gain object. The first one is do not using a rigid body, and the second one is using a rigid body. So when we are using a rigid body to move a gain component, and we have to move the position belongs to the rigid body. So do you see that? The field having the same name of position. They are all having the same name. This is transform position and this is rigid body position. But these two values are different because the transform position is running in main thread, but the rigid body position is running in physics thread. There are some mechanism to sync these two values, synchronize these two values together. And the synchronization costs some operation resources. If we care about the consumption of operation, we should make the synchronization things happen less and less. Otherwise, the power consumption or the operation consumption will be an overhead for our project. It will consume a lot of extra operation power. So that's the consideration behind. And for the physics movement, besides directly move the position, there are some sweeping mechanism for us to be as an options. What is the difference between sweeping an object and teleporting an object? Let me draw a sketch for everybody. So this concept is very important. Otherwise, you'll get your collision erroneously. So we have a character over here. This is our character. Mhm. So we want to move him to the position over here. So is it reasonable for you to directly change the position to the new position? Is it reasonable for you? Direct changing the value from 0, 0, and 0 to 5, 5, and 5. Alright, if you do the things like this way, you are teleporting this character because he is suddenly disappear at this position and shown in this position. This is teleporting. Tele. But if there is a huge wall over here, can he pass through the wall? Yes. Yes. If there are any obstacles on the path over here, the teleporting won't be able to notice about that. So it can teleport even through a wall, even a solid wall. So this kind of movement is problematic if you have some obstacles and should be able to block the character, it will be failed. So another solution is to using the sweeping solution. What is sweeping solution? Let me show you with the help of this sketch. The sweeping will separate different time points along the path. Okay, this is a rough sketch on face, face, and face, and face. So for each step, the character will try to move on a little bit to see whether he is allowed to be moved. So if the wall is over here. So the first step, this is the first step. In the first step, the character is allowed to move. There isn't any obstacle. Correct. But the second step is also kind of allowed to be moved. But the third step, something happened. In the third step of the movement, some collision happened. So the third step will block the character to move on. So namely, the character will be stopped at here. He will not be able to teleport to the unreasonable position over here. The movement will be failed, blocked over here. So this is sweeping. Which one do you like? Depends. Sometimes I like teleport and sometimes I need to sweep. So that's the difference between these two solutions. If you want to teleport something, you can just directly change the position. But if you want to sweep, you have to call move position, or you can change the velocity belongs to the rigid body because physics will calculate the movement for you using the velocity and all the mass behind the physics world. For this field, it changes its name to linear velocity in Unity 6. This is the newest version of Unity, but we are not going to install this version. Okay. All right. So important. Uh, I know you are going to find some tutorial on internet, but some tutorial have some problem. It will be like this. Sometimes you're going to see a YouTuber who is attaching a rigid body to a component, but he used code to modify the position in transform. This will cause some problem. That is the problem of synchronization. What is that? Let me introduce to you. So if you use rigid body position, no, 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 so let me see. Next one. Okay. So if you are using anything in rigid body, like rigid body position, move position, or velocity, this kind of API should be called in fixed update, which is executed 50 times in 1 second. This is in different period comparing to update. So if you write code in this fixed update, it will execute in a different interval. So what if Mr. Fu? What if I didn't follow the rule? I would like to write all the code related to this API in update. What would be the result? All right, if you do that, the result is you have to spend the extra power consumption to synchronize the value. So it will cause some overhead. So this is the very important thing to be bear in mind. All right. And okay, if we use transform position, the transform and the attached collider are updated immediately outside the physicist and the fix step. This will cause more overhead. This is what I mentioned about. Yeah, you can directly change the value over here. And since the render thread is very close to main thread, they are all 60 FPS. So whenever you change the value here, the character will be shown as the new position immediately. But if you use rigid body to change the position, since it's in another thread, it will take some task to be synchronized and some delay will be observed or happen. So this is the important idea behind that. Okay. All right. So the example we saw in last page is using the position field directly to change the value in position and the character moves. Otherwise, you can use transform translate. So we are not going to spend too much time on this. All right. So on this page, we see the APIs which could belongs to the rigid body. So like this one we introduced before, right? This one we introduced before, and the velocity one. So for the sweeping, sorry, for the sweeping methods, like moving position and the assign the velocity the value to the rigid body, it will smoothly um, use the sweeping algorithm like this. So you will be blocked by the obstacle along the path. All right. Okay, so now we move on to rotation. The rotation is having the same situation and the feature to the transformation. So we can use the rotation to assign a new quaternion to the gain object. Wait a moment, what is quaternion? All right, here comes again. The rotation you see here actually is called the Euler angles. In Chinese, it's called Ola Euler is a name of a mathematician, and the Euler angles having three different elements. They are x and the y and the z rotation. So whenever you are going to read the value over here, what you need is to read the Euler angles. But if you are going to read the rotation field, what will be the result? Okay, the result will return you a quaternion. A quaternion is a vector having four elements. This is another math comparing to the Euler angles math. We'll not spend too much time talking about quaternion math. And the core idea of quaternion rotation is to rotate around some axis to some angle. So for quaternion, you have to provide a three-element vector and another scalar value as a rotation angle. So in total, you have to provide four elements. That is quaternion. Comparing to the four-element quaternion, the Euler angle only have three elements, C, S, Y, and Z. So that's a huge difference. So that means quaternion can be more expressive. And if you are facing some problem, like gimbal lock. Gimbal lock is okay, okay, okay. Gimbal lock is a problem when you're using Euler angle to apply Euler angle on camera movement. So sometimes you will having the problem of gimbal lock, but Euler angle can get rid of gimbal lock. Right. Mhm. So in the lessons during the semester, we're not going to use quaternion. All the math, we are going to use the Euler angles version. All right. So Unity provides a rotate function, which allows us to rotate some angle around an axis. So as you can see, this operation is pretty similar to the native quaternion. Hooray! We are if we are going to use a native engine right by our own, we are going to implement the quaternion to meet the function like this to rotate around some axis. It's really hard to use Euler angles to do that, but quaternion is native to that. So we can call rotate to fulfill this requirement. All right. So of course, the above are talking about something that without a rigid body. But if you have a rigid body, there is another rigid body version for you. So of course you can directly set the rotation of a rigid body like this, or use move rotation to sweep smoothly around some starting angle to end angle. And you can even assign an angular velocity and let the physical engine to do the calculation for you. Okay, this is the same thing happen to transform. Okay, all right. So this is the last one. We know that we have two different axes. One is global, and the other is local. So how to transform between global and local? Okay, Unity provides two APIs in pair. They are transform vector and inverse transform vector. If we want to transform from local to global axis, we can call transform vector. On the other hand, if we want to transform from global to local, we can call inverse transform vector. I'm not going to spend too much time on this, and you can find the document over here. Alright, next one. Alright, so now let's move the character to move. So as we can see that the animation pack. Oh, did you download the resource in number 6? Alright, so please download this one too. The resources. So within that resources.zip, we have an animations folder, which have several example animations. Oops. Okay, the first thing is to make everything in humanoid version. 那一种你帮后面好像有人在讨论，所以请他稍微注意一下。All right, so the most important thing is to change everything, including the model and animation, to humanoid, so that the model and the animation could be changed uh, freely to be shared among several different models. All right, so let's check whether the girl is in humanoid version. Select casual one from the sources file and select the mesh. We found the anime girl, right? So this is an FBX format model, and let's check the import setting of it. Aha! So right now it's a humanoid. And what is the avatar definition? The avatar definition means that uh, the avatar needs to be defined from a T-pose. So I think most of the students over here knows T-pose, right? T-pose, when you're posing like a T, the avatar need to be defined from a T-pose. So you have to provide the T-pose mesh. Since this FBX, it has a zero frame number zero posing as a T-pose. So you can create from this own FBS model. And for the other animation I provided, some FBS doesn't contain the T-pose as the zeroth frame. For this kind of FBS animation, you have to point it to the T-pose file for it. Otherwise, the avatar definition will be missing. So later you'll see that I'm going to make an example for everybody. All right, so everything works like a charm. It just okay. And we are going to use a walking animation to animate the character. So let's check the animator over here. From the model prefab, it already contains an animator. So it even provides an animator called AC. So let's check the AC over here. By double clicking the AC in the resource manager, you'll be able to see the content of it. Right now it's a little bit mess. Where is it? Okay. This is my, oh, I'm going to create a new one. Sorry, because this is my last exercise. I'm going to create an animator AC2, and I'm going to assign to the animator over here. Okay. So let's drag some animation into the animator. We're going to check for the walking animation over here. It's located in the whiteboard folder and local motion and walking. Animation, whiteboards, local motion, and walking. So let's expand the walking FBX, and then you'll be able to find an animation inside the walking FBX. It's called mixamo.com. It looks like an advertisement, but it is download from this website. So let's drag the mixamo.com into the animator. 3, 2, 1, go. All right, now I have a new state, which will be able to play the walking animation. If you are curious what is this animation, you can select the animation again. Did you see the double line bar over here? Actually, this bar can be dragged. This is a previewer for your animation. So right now, if you select the animation, it can preview in the browser, little browser. If you don't like the default character, you can drag the character you like into this window, and you can switch the character to another one. Just drag the model over here, from here to here, and you can preview the animation on this model. Okay, do not directly drag the FBX. We know that this is the FBS file, right? It's not. Oops, it can be. Okay. All right. My personal habit is to expand the FBS file and drag the animation inside the BS. All right, now we have some modification to make before we apply the animation to the character. The first thing is that the name of the stage is very, very weird. Let's change the name to walk because this is a walking animation. And the second thing is that probably the animation is not looping. In order to make it looping, we are going to set the import setting of the working FBS. Sorry, the animation inside the working FBS. Select the animation and select the edits. Scroll down, scroll down, and scroll down. You'll be able to find a loop time option. If you want the animation to be looped, just check this option. And before you leave the inspector, remember to scroll down, scroll down, scroll down, and click the apply button to make everything fixed. Okay, so now the animator is ready to go. Just press the play button and you'll be able to see the girls walking. Probably you will see a very weird shadow over here. It's because the shader on this model is not casting any shadow onto the ground. So this is a bug. But we are not going to fix that because we just take it as a practice. And if we can write some code to move the handle according to the step, and it will make the girl look like, oh no, oops, what happened? Oh, okay. All right, I just forgot to lock the rigid body. Sorry, I may not. Okay, let's go back. For the player handle, well, I forgot to lock the rigid body. Sorry, I'm going to add the information into the slide. Okay, let's expand the constraints on rigid body and lock the freeze SYZ rotation. Will not allow the physics engine to calculate the rotation and apply new rotation for this character. We are going to use code, use C# code to rotate this character. All right, after this little tweak, and next time we can move the character by moving the axis on moving the axis value, and then you'll be able to see she's working. Yeah, great. So let's write some code. Okay. Okay, this is it. This is the first time you use design pattern to implement a character movement. Let me introduce what is this design pattern. This pattern is called a template method. A template method will be like you have a series of operation, begin, middle, and end. So for all of the operation you are going to do later, they all have a begin, middle, and end three-step processes. But you just don't know what is the concrete task to be implemented in each of the steps right now. I just know that for each of the input signal, I have to calculate the D path signal and the A button signal and the B button signal, but I don't know whether my joystick will be like this or like this, or even a custom-made, a handmade controller. So right now, I just know a very abstract idea about my controller. I have to write everything in abstract style. So this is the abstract input manager over here. Let's take a look at this. Here we declare an abstract class having a named input manager. Later, we are going to inherit from this input manager to implement a keyboard input manager. Maybe sometimes, some days later, I'm going to make another joystick input manager. Maybe some days later, I'm going to make a Arduino input manager or something like that, right? But right now, I just have a very abstract idea about that. So let's take a look. What is the code inside the abstract class? So this is D-pad, directional pad. We know that. So we are going to use an event center taking as an event D-pad access. So whenever we had an updated D-pad value, I'm going to broadcast the value through this Unity event. Okay, so this is the event center. And besides that, I'm going to save the access value And in order to pass the access value to the subscriber, so I have to keep the access value right now. Actually, I have two assets, but I declare the assets like a vector 3. This is this could be reduced to vector 2, but I didn't notice about that. So let's just temporarily put it like a vector 3. Okay, so later I'm going to declare two methods. The first method is to calculate the dpad access. Whenever I execute this method, my concrete input devices will calculate the dpad value for me and return the value to access. All right. And after that, I'm going to do some math on the access value. And temporarily is an empty method. But later we are going to use this method as an appendix to fix some bug. All right. At the last of update, I'm going to invoke the event and pass the access value to every subscribers. So this is a template method. Okay, after I finish this input manager, I'm going to inherit from it. So I made a keyboard input manager. All right, here is the most important thing. Since I inherit from input manager, I have to make some concrete methods for the abstract method. So the first method to be overridden is calculate dpad access. And since I have a keyboard, I can use W and the A, sorry, W and the S. This is wrong. This should be S. Whenever I press W, the Z axis should be 1. Whenever I press S, sorry, be careful. This is a typo. Here, this should be an S, okay? Whenever I press S, I will get a -1 for Z value. So this is the vertical axis. And for the horizontal axis, whenever I press D, I get a 1 for my S. Whenever I press A, I get a -1 for my X. So this is the specialized, the customized logic on my keyboard. Ooh, alrighty. So next, whenever we finish the input manager design, now we are going to focus at the player controller. The player controller should be inherited from mono behavior because it will be attached to control the player handle. So line number 5 declare a velocity which will be applied whenever the character is moving. And line number 7 just declare a moving vector which will be a temporary value whenever we receive any access from the input. So in the update, we're going to translate the character according to moving vector. So we just multiply the moving vector to our velocity. As long as the velocity is large, the overall vector will be large. And we have to take the time into consideration too. So that's why we multiply the product with a delta time over here. The delta time typically will be around 20 milliseconds, but it depends on what is the situation, what is the actual situation your last frame take from your on your machine. So this is the movement we are going to apply on the gain object. And the second argument specify whether the movement is taken on self coordinates or world coordinates. And in this example, we are going to apply the movement on self coordinates. So that's it, simple, right? And at the last, we're going to declare a subscriber method. I'm going to give you a name move. And from the definition over here, the signature, the delegate, should have an argument, the only one argument as a type of vector 3. So of course we are going to obey the rule over here. So the only one argument will be vector 3. Whenever the subscriber is triggered by the event, we're going to save the vector passed by the input manager and save it to the moving vector. So this is it. I need your help to finish the code. The page number is number 16 and number 17. So after that, you can bind the two classes and you can assign the input manager. Oh, all right. So you need to add another gain object to put the input manager on it. I'm going to call this one an input manager. Input manager. Maybe keyboard input manager. Keyboard input manager. And put your component on it and to bind the two things, including the controller and the manager, input manager. And let's make the result like this. All right. So since this is the first time you implement the structure, let's take 10 minutes to do that. Okay.哎，电门那是吴佳丽来让来 demo 的吗？哦，OK，我怕你不认识他，应该就是他啊，那个啊，那是吴佳丽啊，对的，嗯， Okay, I think I can. We can take a 10 minutes coffee break. Okay, so let's go back 10 minutes later.
handle 就是那个行李箱那个上面那个哦，就是这个东西，就是外面的 capsule。我们的 structure 就是最外层是一个 handle，然后里面包了一个模型跟一个碰撞器。哦，那这个 handle 就等于是我们要请物理引擎去算它的整个位置，我们要界定出一个 collider 给它，所以 handle 上绑了一个 capsule collider。那你一个小时上面可能会有多个 collider，比如说像那 Street Fighter，就是那个街头霸王那个快打旋风那种游戏，它有移动碰撞光、攻击碰撞光跟防御碰撞光三种，这三个可能会分开实现。那如果你没有特别要做那么复杂的游戏的话，那一个移动碰撞光应该就够了。那这个就是这种情况。那如果你有额外碰撞光需求，你就会在底下再加额外的碰撞器。那今天我加的 Sphere 碰撞器，它其实未来会是某一个感测器之用的，也是很像的概念。不过现在先没有要用它，这就是它整个的架构。那以后会是 sensor 在这边有它的程式码，如果它察觉到什么东西，我们会在它身上也做 event。那执行的方法就是从别的脚本挂上去 sensor，然后看要传给谁这样子。哦，对，4点之后我还是会在，对，我都会弄到半夜。哦，没关系，好，没问题。Yes, Ethan. What do you mean? Sorry, you mean the midterm project? Okay, so the deadline is next week. Mhm. Oh, which project? Project A or B or C? Okay. Um, okay, so, well, yes, yes.
Okay, welcome back. So, in the last hour, we make a walking character. Okay, what is shown on the screen is my temporary script, and if I rotate the handle by directly rotate it in editor like this, look. So now the anime girl is pointing to some slanted angle, and if you press W, it will walk to a new forward angle. So this is pretty good. But if we change the code so that the moving logic is different, maybe the second argument, let me change the argument to space dot world. So what will happen? Let's have a try. So if I switch the code to be like this, and if I rotate the player handle, and this time, even if the player handle is rotated, the moving angle doesn't. This is not what I expected for the movement. So I have a conclusion. I should set the second argument to space.self. This is fulfill my requirement. The reason why is because the vector we described over here actually is under the concept of local access. So that's why we have to set the second argument as space.self. Okay. Simple question over here. So let's move on to the next topic. Let's make a fixed camera. Just like we see before, we have several policies for moving the camera in different kinds of game. Let's start from the right to the left side on the list over here. From the right hand side, the first one we see over here is a third person to the top down. What is that? This is a Pac-Man. This is a Pac-Man, right? So a Pac-Man is a top-down view game. Whenever you press right, the Pac-Man moves right. Whenever you press up, the Pac-Man just moves up. So this is top-down. But this is different to the Super Mario. The second one is third-person 2D platform game. For 2D platform game, whenever you press right key, the character moves to right. This is correct. But whenever you press the up key in Super Mario, what will happen? Nothing will happen. So whenever you want Super Mario to jump, what key should you press? The jump key, the A key. So the camera device what key should be able for the player's movement, right? So camera view is very, very important. It gives a sense of control. So camera is related to the operation. So that's why we have to decide how to handle the camera first, and then we're going to design the logic for the controller. So the same things happen to the first 3D free mode game and the third-person 3D lock-on mode. So what is lock-on mode? Uh, if you have ever played Dark Souls or some similar 3D RPG before, you can lock your target to some enemy. So whenever you lock your target on some enemy, you are under lock-on mode. Under this situation, whenever you press the up key, you're walking toward the enemy. Whenever you press the right key, some different things happen. You will rotate around your enemy. So this is the different things comparing to a free mode. The free mode and lock-on mode is the most important modes in 3D RPG game. But today we're not going to talk about that. Today we're going to deal with the simplest one. We're going to deal with top-down 2D mode. So always remember two things before you start to write your controller. What happened when you press up and what happened when you press right. Next. So for this example, we're going to make a 2D top-down. So under this design, under this scheme, whenever the user press up, the character should move to north. Whenever we press right, the character should move to east. Great. One thing to be noted is that we have to avoid the slanted movement because, like Pac-Man, let's take this as an example. What will happen if I press the up and right at the same time? Maybe go up or maybe go right, but never goes to northeast, right? So we just accept one from the four possible angles, including top, down, left, right. So we have to avoid the slanted movement. So how to do that? We're going to rewrite the code inside calculate by axis in order to block the slanted angle. We know that from the last implemented code, let's try to press W and the D key together, or oops, okay, I didn't mean that. Okay, so as we can see that under the code we just written, we can move in slanted angle, but I'm not going to allow this kind of movement anymore. So I have to modify the code. How to do that? Simple. And let's modify all the code. You'll see later. We're going to modify the code. One sort would be like Mr. Fu. If you don't want the user to take a slanted angle, the easiest way for me is to use else if. How about that? How about that? Well, I will say that yes, you fulfill the requirement. If you write your code like this, your player will never be able to press two buttons on D-pad at the same time. But I'm not going to do that because I'm going to keep the flexibility of this code in order not to block some future features. Maybe some days later I change my mind. Whenever I press a slanted angle, I will trigger some special skill. But maybe, I don't know right now. So I'm not going to change the code over here. On the other hand, I will try to detect the angle before I apply the vector onto the character. So my decision will be like this. Let me introduce the modification. Just like we can see that we're going to this time we're going to rotate the model, so we have to know who is the model. I declare the model over here. The model should have a type of gain object. We know that, and starting from line number 13 to 14, we're going to project the vector into some right axis and the forward axis. Currently, I'm going to project my moving vector onto the world right vector and onto the world forward vector. So this is a dot product. So you can search on internet what is dot product for two vector. This is the vector mass vector operation. Let me draw the sketch. I'm afraid. Okay, let me introduce the dot product within maybe 5 minutes. Dot product. Dot product is also called a inner product. Of course, we have an outer product, but today we are interested in inner product. If I have two vectors, the dot product is calculating the cosine theta. This is a right angle. So if I have a vector A and the vector B, so I'm going to calculate. Let me change to a red color. Calculate A times cosine theta. And what is A times cosine theta? Actually, this is the length over here. This is the projection of the A vector onto the B vector, and I got the length by dot product. This is the dot product. Sorry, this is the I shouldn't draw the arrow angle here. This is pointing to this direction. This is the projection vector. But A cosine theta is a scalar value, so this represents the length of the projection vector. And by simply doing the dot product, I can get the length of the projection vector. Easy, right? So if let me draw another sketch. Oops. So if the user has an input pointing to this direction, so what's his intention? He is trying to move roughly to the right, but a little bit heading to the north, right? So in order to get his intention, I'm going to do two times of projection. The first time, I have to figure out the intention. Is he trying to move to right? In order to figure out the intention, I can do a dot product. I'm just trying to, this is moving back, right? Sorry. Let me address this mvac, moving vector. And this is our right vector. By just simply doing the dot product between these two vectors, I can know the intention. Is he willing to move right or not? And the second time I'm going to do is to figure out, is he trying to move to north? The intention for this player, the intention to move to north could be get by simply doing a dot product between the m vector and the north vector. East and north, okay, right. The right means east. So that's the code address over here. In order to get the attention from the player, I declare two variables. The first variable is moving vector horizontal, and the second sorry, this is a scalar, the float. The first float is moving back h. The second is a float of moving back v. These two flow values are derived from dot product. So starting from line 16 to line 19, I'm comparing these two components. Whenever I found that the horizontal length of projection is large, that means my player is trying to willing to move to right comparing to move to north. Then I can neglect the north component and only focus at the right component. So you see, I'm comparing whether h is larger or equal than vertical than v. If this happens, I will keep only the h component. So if this is the case, I'm going to multiply the moving back horizontal to the vector 3 right. So since this is a scalar value and this is a vector value, the product of these two things will be a vector. I'm going to save this vector back to the moving vector. Okay, and whenever the other happens, that means the h is less than v. I'm doing the other side. I'm going to save the v component back to the moving vector. So this is to regulate the movement. And after that, I'm going to take whether now my user is moving, is pressing any button or not. If the moving vector is greater than zero point 0.1 float, that means something is happened. My player just show some intention. So, Mr. Fu, why you write code like this? I think you should write when the magnitude is not equal to zero. Shouldn't I do that? For a software engineer, will never do that because sometimes you will get a very, very small value, like uh, for exponential minus power of exponential power is the exponential of minus 10 times like this. So this kind of value is very, very trivial and small, but this is not zero. So in order to get rid of the arrow, we are going to use a dead zone for that. So if this happens, that means our player has some intention. Then we are going to rotate my model. So directly by assigning the forward vector of this model to a new vector, the model will rotate. So this is the simplest way I know to rotate the model. Actually, this is a trick. Mhm. And then I'm going to move the capsule. This code should be work like before. All right. So if you finish the code, that will be like this. So very quickly, you implement a four-directional movement of a top-down viewer. All right, so let's take about 5 minutes to modify the code. Okay, so the part should be modified. The part to be modified is only included in the player controller class.
我是谁啊？还做动画？
不错不错，太好了，我还蛮有爱。
嗯，对，这种这个是另外。啊，很重的。你说刚刚锁死这个吗？没有，因为好像真的。
Okay, by simply matching the step and the velocity, you'll get a very vivid movement, like she is really stepping on the floor. So you can try by yourself. On my machine, I will set the velocity to 1.4, around 1.4. For this velocity, the animation will perfectly match the speed, and the result is will be like this. You can see that for actually the step is sliding very slightly. So it looks like she's stepping on the ground. Interesting, right? Okay, let's move on to the next topic. Great. So let's add some camera. And for camera logic, we are going to use one extra lesson to talk about how to set the camera correctly for both free mode and lockup mode. But temporarily, we're just going to tie the camera onto the handle. So it will be like that. And the result will be like, and whenever you are moving, the camera will follow your position. It's a little bit lag. Okay, let's do it. So we had a main camera already. This is by default the scene created for us. I'm going to drag the main camera into the handle, into the player handle, but I'm going to reset the camera position in order to make the camera to be put at the foot of this girl. And then I'm just going to drag this little box in order to make it move on the plan. So take a nice angle and position. This is it. Okay, this is my final decision over here. And now my camera will follow this girl. Simple, right? So let's do it. Please tie a camera to this girl. So easy, right? In a very, very short time, you'll have a top-down view camera. Of course, you can change the angle and position in order to make it like this, right? And it will be pretty like the isometric angle. Some games will be rotated like this, and there will be a huge maze in order to let you to see a roughly a large enough area in order to get escape from this libris or the maze. Okay, but right now I'm prepared to put the camera like this. Okay, let's come back to the lesson. And then next, we are going to implement the idle movement. So in order to play the idle animation, the first thing is to drag the animation into the animator. Oh, the animator can also only play the animation within the animator. For the animation which is not being put into this window, those animations are not allowed to be shown on this character. Alright, so let's find the idle movement animation. I should put the idle animation in this folder. The local motion actually is a typo. It should be LOCO, 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 MOTION, local motion. Well, no, this one. Okay, this one, idle. So let's have a preview to it. Okay, this is idle. Great. So open our animator and drag the idle animation into the animator and fix the name to IDLE. Alright, so now we have an idle animation to be ready to play. Okay, so with some simple modification, we'll be able to see the idle animation working on the character. So let me explain the code over here. So open the player controller. This time we're going to get the animator which is attached to the model. So let's use get component, but please do remember we should call get component on model. Okay, so we called the get component on model because this is a component attached to this model. So whenever we get the animator, we'll save it in the name variable. This is actually a reference, not a variable reference. So later, whenever we found that my user has some intention to move, and then I can switch the animation by calling this API, by calling play. So in line number 34, I just call anim.play, and the only argument is the name of the state. This should be walk. Sorry, in my system it should be walk. So please match the name in your environment. So on the other hand, if the player doesn't want to move any direction, and then I can play the idle animation. Okay, so let's make the modification like this. Okay, if you're looking for a much more vivid representation that will have a blend effect between starting to move and stop the movement, as we can see that when we start to move the character, there is a burst. Suddenly, some large poses is taken action. So this is not natural. If you don't like the natural behavior, you can use another API. It's called crossfade. Crossfade with a fixed time. There are two versions. The one version is crossfade with fixed time. So in this version, you're going to use the walk and since I crossfade in fixed time. Yes. So you have to assign the second argument for the duration allowed to blend in between the two animations. For me, I'm going to assign 0.1 seconds. So um, let me do the same thing for the second play. So I'm going to comment out of the play, comment out of the play, and use crossfade. Okay, this has a very nice improvement in blending the two. Oh, sorry. Now it's just Twitch. Well, actually, we can just call this for once. So, right, not now. Next time, when we are using the finite state machine to have overall control, for example, using the on enter is state and on axis, and we can flawlessly use the crossfade in our structure. But right now, we have no idea where to implement something for once, something that could only be coded for once. We need some extra flags to do so, but that will cause another variable to be declared. So not right now. All right. Okay, so let's come back to the PowerPoint slides. Okay, next, let's implement the blockers as soon as possible. So the easiest way to stop the player, as we can see that now she's like a ghost. He can run into anything she like. In order to block this anime girl, we have to apply physics on her body. So push out sound. For the physics engine, how the physics engine prohibit this girl to enter this box? It will separate it into two steps. The first step is to update the girl's position. Whenever whenever the engine update her position, sometimes she will be allowed to enter the obstacles over here. And then the second step will be applied. For the second step, it will analyze who is inside an avoid region. So if in second step the engine detects, oh, this girl is in some forbidden region, she had to be pushed out. And then some push out algorithm will be performed and the girl will be pushed out. So what is the push out algorithm? Well, it determines where is the front and where is the back of this character, and then apply some distance to pointing to the back direction. So whenever the girl is entering some forbidden area, the push out logic will push her to the back direction. So this is what the physics engine does for us. But we are not going to dive into the deeper of the push out algorithm right now. All things we have to do is to apply a rigid body on the player handle. I think we already have one, don't we? Let me check. Oh, yes. We already put a rigid body on the player handle. And we already froze the rotation in all the three directions, in X and in Y and in Z. Great. So we can go to the next one. All right, so let's write some code to update the velocity of this girl. So let's, as we can see that since we add a rigid body, we can get the rigid body component when the code starts. Well, we can either get the component in awake or in start, and either will be okay for this code. So after we get the reference to the rigid body, we can apply some velocity to the rigid body. So in the before example, we just translate the girl, and that will make a teleport effect, just like we discussed before. Did you remember the goes the teleport? Because we are just assign the point, assign the position directly. Okay, this we were doing things like this. Either translate or directly assign position will make it teleport. But right now, we're not going to use the teleport way. We're going to use the sweep way. So this is how we apply the sweep way algorithm. We just assign the velocity to rigid body velocity. Simple, right? So after that, our player will be blocked by the rigid body. So let's take about 5 minutes to implement the code over here, okay? Okay, so I think for the falling and jumping parts, which in the last three topics, we may not able to address the topic content in this lesson, and we are trying to put these three features in the next lessons, okay? Because the time is running out. So let's pause at here. Before you leave the classroom, would you please do me a favor to finish the blocking feature? So let me just Let me show you on the screen. Okay, so now we almost finished the controller. Uh, we can use the controller to navigate the player to anywhere we want. And even with a slope, just like this, you can try and make a slope. So since this is a rigid body, sometimes you'll see that she has some problem climbing, and yes, she has some problem falling onto the ground back to again. Just like a balloon or something. All right. But if you're interested in how to make her falling, you can follow the instruction on the PowerPoint slide, or you can wait for next lesson. I'm going to introduce by myself. Okay, so this is the lesson today. Do you have any question or problem? Okay, if you have any question, you are welcome to contact with me, and I'm going to show you the detailed design of each of the details. So let's call it a day. Thank you for your attendance. Yes. Oh, you mean the midterm project? No, 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 no need to presentation. Okay, let me explain. Typically, you are going to arrange some presentation, right? But this time, we may running out of time. Introduce the content of this class content. So, would you mind to use the video recording? Okay. So, is everybody taking this course sitting over here? Okay. I will need your help to use 3 to 5 minutes to introduce your project and upload the video um, as a homework. I will open the homework as a on the iStudy, and would you please record a very short video from 3 minutes to 5 minutes to introduce your project, and I need your help to upload all your codes, just like what I written in the requirement document. I need your source code, need your exe file, and I need your a PDF file to introduce your cost diagram or flow charts. And with the help of 3 to 5 minutes recorded video on YouTube, just show me the link is okay, and upload to the iStudy, and let's share the representation, share the video to each other. All right. I'm sorry because you know that there is another typhoon coming, maybe tomorrow. Yeah. I, I'm not sure. Maybe it's not the last one. So sorry. Unfortunately, we are running out of time since there are too much typhoon this year. And but I'm glad that you spent so much time on. It's still going, but I think we're, we're still having to work tomorrow because in Taipei City we don't have a so severe typhoon in Kaohsiung. Oh, oh. Okay, so maybe see you next week. Okay. I will notice the what I just told everybody onto the iStudy system. 3 to 5 minutes video recording.这是哪一件？吓我！
这个被退零也很好笑，他说用途不可为办公用品，因为我不小心打了办公桌垫，他们不开心，要我改成桌垫，然后老师要盖章，说老师改的。
这是哪一项啊？
就是
桌垫。
对桌垫。
它原本是什么
？DP02，因为我也不知道什么都会乱写。
哦，对不起，对不起。
没有，不用，这没差，因为大家 DP 系列都乱写。
对，我先把 recording 好。